Hello students, hope you are doing well and you are also studying well during this lockdown. Alright, welcome to this video. So before we begin with today's concept, which is arithmetic mean, let me discuss first what we had spoken about in the last video. So we had spoken about cumulative frequency in the last video. So cumulative frequency is such a statistical technique or statistical measure that gives you how many out of the total distribution are beyond one particular limit or below one particular limit. So this is how the cumulative frequency gives you the way, gives you the approach towards the entire distribution. So that makes you to help you to understand out of the total distribution how many are there at below of one particular limit or above one particular limit. So we have basically two types of cumulative frequencies, less than cumulative frequency and more than cumulative frequency. So you can have any one partition among in one entire distribution where you can find how many items are lying before this limit and after this limit. So this is how it will make you to understand in one particular limit about the total distribution. So that is what we discussed about cumulative frequency in the last video. So today we will be talking about arithmetic mean. Some of you already know this with the name of average. So everyone knows about average. How do you find average? So average is the sum of all the elements divided by the number of elements. That gives you the average. Okay. So now for example, if these are the numbers, then to find the average of all of them, you have to add all of them divided by, there are around, yes, there are 7 numbers. So this is how you find average of the number. So what do you mean by the average, or what do you mean by arithmetic mean? So the meaning of arithmetic mean is, it is such a value that can be replaced for almost all or most of the values in the entire distribution. Okay. So the arithmetic mean, I repeat the definition, is such a value that can replace all the values or most of the values in the entire distribution. It is one value which gives you the representation of the entire distribution. That is what the meaning of arithmetic mean is. So now this arithmetic mean is totally fit or applicable in some kind of data sets only. Alright. So the main thing is that if the items in the data distribution or items in the data set, they don't have much deviations or much difference, their deviations are too less or at the time negligible, then arithmetic mean can really replace most of the elements in the entire distribution. Okay, so if the fluctuation between the elements or the deviations between the elements are too much or too big, then arithmetic mean cannot really fully represent the entire distribution. So in the case where you have a normalized data distribution, normalized distribution of the values, where we have fluctuations of negligible and most of the values are in the one particular range of the central part, then arithmetic mean can really represent this entire distribution by giving one value. So that is the meaning of arithmetic mean, and in these cases it is mostly applicable. Okay, so now for this example, if I want to find the average of these values, or you can say the arithmetic mean, so sum of them is 11 plus 8, 19, 26, 34, 41, 47. So this gives me value 6.7. So now 6.7. So 7 is, these two values are very much near to 6.7. Alright. And then these two are compared to 8 and 5. These two are also near to 6.7, and 5 is not near to 6.7 as compared to other elements. So we have one such element which is much away, which is much at the much distance from the arithmetic mean. So this is how most of the values, like all these values you can say, those can be still represented by the arithmetic mean. So arithmetic mean helps you to understand the entire distribution by understanding on an average what will be the values. Values will be near to one particular value arithmetic mean, around those most of the values of the entire distributions are there. So this is how arithmetic mean makes you to understand about overall distribution. Okay, so even though you cannot replace all the values in the distribution, but most of the values of the distribution may be again around the arithmetic mean value. So this is how it makes you to understand the data about arithmetic mean. Okay, so now basically basic formula for arithmetic mean is the sum of all the values, the sum of all the elements in the distribution divided by the number of elements. So this formula remains same, only at the places where we have different kind of sums, there we applied it in different ways. Okay, so now let me take one example for arithmetic mean. So now here value x and along with their frequencies are given. Alright, so now this data is given in one different form, like 11 is there 6 times in the entire distribution, 12 is there 8 times, 13 is there 15 times in the entire distribution, and so 14, 15 are there 6 and 5 times. So this is the frequency of each element is given here, right? Now how you are going to find the sum of all the elements in the distribution and the number of all the elements in the distribution. These two things are required to calculate arithmetic mean. It is the basic average formula again, that's the sum of all the elements in the entire distribution and the number of all the elements in the entire distribution. So we don't have all the elements of the entire distribution. We have 5 elements from the distribution which are repeated multiple times. Okay, so 11 is repeated 6 times, 12 is repeated 8 times, and so on. So now 5 elements repeated so many times, so those every entry we have to consider and we have to calculate the number of elements in the total in the entire distribution. So how we are going to find those? So now there are 6 11s, 8 12s, so how many such elements are there? Okay, so for that we need to calculate we need to add all the frequencies. That will give me the number of elements in the distribution. Okay, so now let me add all of them. So 40 is the total. There are 40 elements in the entire distribution. So total entries are 40 and distinct values are 5. Those are repeated and all together that makes 40 entries or 40 items in the distribution. So we have got this denominator from our formula, that is we have to divide the sum of all the elements by 40 in this case. Now how we are going to find out the sum of all the elements? We are not going to add just 11 plus 12 plus 13 plus 14 plus 15. That will really not give me the sum of all the elements. 11 is repeated certain number of times, that is 11 is repeated 6 times. So first I need to calculate the sum of only 11s. So 11 adding 6 times, in short multiplying 11 with 6, that will give me the sum of all 11s. Similarly I have to find the sum of all 12s and then sum of all 13s, so on. So in short I have to multiply each item along with its corresponding frequency. So that will give me the sum of each item however number of times it is repeated. So these all multiplications, then I have to add, that will give me the total of all the elements in the distribution. Okay, so now let me add one more column called as fx. So now what this fx column is about, we have to multiply this number, this item along with its frequency. So here I have to write the multiplications. Okay, so this is how I have calculated all the multiplications. Okay, so let me denote it as n here. Alright, so I have to add these all. So 516 is the total. So 516 is the total of all the elements in the entire distribution, that we have to divide it by 40. Okay, so now one thing, we will also observe the frequency pattern here. Now look at the frequencies given in this way. Initially it is 6 and then 8, then 15, then 6 and then 5. Okay, so pattern you understand, 6, 8, 15, 6, 5. So this kind of pattern is called as the normal pattern, or you can say normally distributed frequency. So look at the central one, the frequency is the third one, which is with the highest, it is 15, and on the both the sides of 15 we have 8 and 6. So 8 and 6, there is a difference of 2 each, and then the other two frequencies are 6 and 5, there is a difference of 1. So now this way, when you have the frequency in the normal shape, you can expect the arithmetic mean in the central part. Okay, so the central part here is the frequency 15, whose with the item related is 13. So you can really expect that arithmetic mean of this entire distribution will be very much near to the 13, or it can be 13 itself. How you can conclude this? Because you have to study the frequency pattern. If the frequency pattern is normal distributed, then we can say at the central part you will always get the arithmetic mean. In this case, we may expect it to near to the 13. Okay, so now here I need to calculate the so now for this particular sum, let me edit our arithmetic mean formula. So it is the number of this is the total of all the items in the entire distribution. So arithmetic mean is where we have found the summation of fx. So arithmetic mean, when x and with frequency is given, is summation of fx divided by n, where n is the frequency. Alright, so summation of fx we have calculated is 516 divided by n is 40. So let me calculate. So we have got the value of arithmetic mean, which is 12.9. Okay, so we had assumed, or we were assuming that the arithmetic mean value will be either 13 or very much near to 13. So 12.9 is much near to 13. It is just 0.1 away from 13. So as we had expected, we have got the arithmetic mean value near to 13. It's 12.9. Okay. Now there is one more specification here. So, say the central value is 13 with maximum frequency. We got the value 12.9, which is again little less than 13. Okay. Now, if you look at the frequencies before 15 and after 15. So, before 15 we have frequencies 6 and 8, which together makes it 14. And after frequency we have after 15 we have frequencies 6 and 5, which makes it together 11. So we have more frequency before 13. That's why where arithmetic mean is coming just before 13. Because though 15 is the maximum frequency which is contributing to the entire distribution, the first half of the frequency is again more than the second half of the frequency. So our arithmetic mean is little towards the left part after of the 13. That's why we have got is 12.9. So this way also you can verify or you can justify whether the arithmetic mean value you have got it correct. Okay. So the basic formula remains same, that summation of all the elements. So only the way to find the summation of all the elements is little different here. But the basic formula is same, that summation of all the elements divided by the number of elements. It's the same average formula. Alright. So hope you have understood this particular problem. Now different kind of problem will take. Okay, now have a look on this problem. Now the values are given, it is in the different form. You have got class intervals with width of 20 everywhere, 0 to 20, 20 to 40, 40 to 60, 60, 80, 80, 100. Along with their frequencies like 11, 14, 35, 28, 12. Okay. Now we don't know which are the actual elements of the distribution. We know that there are 11 values between 0 and 20. Those 11 values can be all 11 different values between 0 and 20. Those 11 values could be some values with repeated multiple times between 0 and 20 again. Those 11 values can be anything between 0 and 20 with repetition, without repetition. So we literally don't know which are the values from the actual distribution. Which are the values are there from 0 to 20. Only the given thing is like 0 to 20 there are 11 values. So we don't know which are the 11 values. In the previous case we knew that 11 is repeated so many times, so exactly 11 into 6 gave us 66. That was the sum of all 11s. In this case we don't know the values, only we know the range in which. So the total range of value is from 0 to 100. Okay, so the maximum minimum value we know. Now in this case, how we are going to find the sum of all the elements and how we are going to find the number of elements in the distribution. Now for the number of elements in the distribution, it still looks possible because frequency is given. We have to just go on adding the frequencies. That will give me the total values or the total items in the entire distribution. But how we have to find the sum of all the elements in the distribution? That looks difficult. Now, Also now look at the frequency pattern here. It's 11, 14, 35, 28, 12. It's again increasing, then at the peak and again then decreasing. So it's in the normal form. That's what you can say. So 11, 14, 35, 28, 12. Now again if you look at the central part, which is 35 with highest frequency, 14 and 11, the first half is total having 25 and the second half, that is 28 plus 12, is having 40. So what you can say that the central part and the second half, they are contributing more part of the distribution. So even in the central class like 40 to 60, we may expect our arithmetic mean between 40 to 60, in that also incline towards right side. So between 40 to 60, even if you find the middle, that will be 50. So that arithmetic mean we can say still near to 50 but more than 50. This way we can expect. Okay. So alright, so we can find out the number of number of items here. So there are total 100 items exactly. Now how we have to find the sum of all the items? Now there is no point going back to the raw data. If we are going back to the raw data, then what is the use of this data? So this way if you present the data in the statistical classes, I mean in the class intervals, that also gives you some understanding of the entire distribution. So we have to make use of this only, and then we have to find the number of, the sum of all the elements. Okay, so from 0 to 20 there are 11 elements and we don't know which are those 11 elements. So now the one solution is, from 0 to 20 we have to consider one such number that could be the average of all of them. Okay, so now again from 0 to 20 which numbers are there, those numbers we don't know. So it is also not possible to find the average of those numbers. So the one thing is, we have to consider the middle number, the central number from 0 to 20, which is called as the midpoint. So we will be considering midpoint for every class, that we would assume that midpoint of every class will represent all the numbers in that class. So this is how we have to deal with this. So we have to find the midpoint of all the classes. So how do you find the midpoint, by the way? To find the midpoint, it's easy. The lower limit plus upper limit divided by 2. So that will give me the midpoint of every class. So now let me add here one column called as midpoint, which I denoted as M. So lower limit of my first class is 0, upper limit of my first class is 20. So 0 plus 20 by 2, that gives you 10. So 10 will be the midpoint of from 0 to 20. So we would be assuming that 10 is representing this entire class and there are 11 such values. So similarly from 20 to 40, 20 for 40 divided by 2. Okay, so now the pattern is like this. Once you find one midpoint, then you can go on adding the class width to that midpoint. So similarly you go on getting the next midpoint. So the width of the class everywhere is 20. So if I add 20 to 30, I would get 50. And if I add 60 and 40 divided by 2 will also give me 50. So similarly you would find the midpoints like this, that is 10, 30, 50, 70 and 90. So this way you have found the midpoint. Anyways, we have assumed that every midpoint will represent its entire class. So now the frequencies which I have calculated, those we are going to multiply with this midpoints. So we will assume that the midpoint 10, and that 10 is nothing but the representing the class 0 to 20, in which there are 11 values. So we will multiply 10 with 11, we will multiply 30 with 14, 50 with 35, this way. So I add one more column here, which is FM. So that you have to multiply frequency along with its midpoint. So this gives me So these are the values we have got. Okay. So now once we have multiplied frequencies with midpoints, next thing is we have to add all of them. So we have assumed that between 0 and 20, so let's say their representative is 10, or you can assume that the average of values between 0 and 20 could be 10. Then that 10, we have such 11 values in this class, so this 11 we are multiplying with the 10. So we assume that 110 is the sum of all the elements between 0 to 20. 420 is the sum of all the elements between 20 and 40, and so on. So if you add all of them, you would get the sum of all the elements in the entire distribution. So 5320, this is the summation we have got. Even now the calculation of arithmetic mean looks simpler here. Alright, so now for this problem where class is given, classes are given along with their frequencies. So the arithmetic mean you calculate the summation of all the elements, that is summation of, you say, Sm divided by some number of elements, that is n. Now for, in this case, we have 5320 divided by 100. So calculation is very simple. Now it is 53.2. This is the value of arithmetic mean we have got. Alright. So we had assumed the value, the class. We had assumed that 4060, this class would be the arithmetic mean class. So you would expect the arithmetic mean between 40 and 60. In that the center is 50, and then we also predicted that the second half is contributing more in the distribution. So arithmetic mean would be little inclined towards right side. So similarly 53.2, so it is just more than 50. So 53.2 is the arithmetic mean what we have got. So this way also you can verify whether you have calculated the correct way. You have calculated in the correct way the arithmetic mean value. So every time you have to understand the frequency distribution, that will make you to understand where could be the arithmetic mean value, or nearby which class or which value. Okay, so both the examples we have taken so far of normal distribution. First example was with the first half with more frequencies, and this is with second half with more frequencies. So that also makes little difference in your arithmetic mean. So the thing is, like, you have to observe the pattern, the frequency pattern. Alright, so this is the simple way, this is the normal way we calculate the arithmetic mean. There is one more way to calculate arithmetic mean by using the shortcut method. So that we will discuss in the connecting video.